So did anyone have any questions on the homework from that's due tonight over Pythagorean theorem? Cool. Seeing none, I did have a quick question for you guys over that. Mind if I ask you?
Sure.
Cool. Sounds good. Pull that up real quick. So this is from question 1 on your homework. It was, I had my triangle here, I had my side lengths of 3 and 3, and this was labeled as a right angle. What was the length of my hypotenuse? Did any of you guys remember? So you guys had a round to the nearest decimal more than likely. When I want it in simplest radical form. So what did we learn on Friday? What did we focus on? What formula did we use all day?
Pythagorean theorem.
Pythagorean theorem, which is?
A squared plus b squared equals c
A
squared.
squared plus b squared equals c squared. Cool. And we needed to solve for c. We needed to solve for that hypotenuse. In order to do that, what do I have to do? Well, I take 3 and I square it, and I take my other 3 and I square it, and that gave me that I have x squared. What's 3 squared?
9. Is it 9?
9. And then 9 again is equal to b squared root, or is equal to x squared. 9 plus 9 is 18. So I have 18 is equal to x squared. How do I undo that square root? Or how do I undo that x squared? What do I need to do to both sides?
Divide.
Not divide.
Somebody said it.
I need to take the square root of both sides. When I do that, I get that x should be equal to the square root of 18. We can't keep that as the square root of 18. We spent a whole day simplifying radicals. What are two numbers that break down in 18 that I can use in order to find out what I can simplify it with?
9 and 2.
9 and 2, and then 9 breaks down to become
3 and 3.
3 and 3. So there's my partner pair. They can join and come off the bus. When they come off the bus, I get that x should be equal to 3, who came off. Radical, who's still left?
2.
2. So that length of x is 3 radical 2. I got another one. So here's my triangle.
Can we write this down?
I was going to say, so you can. This is going to be basically a review. We're going to run it into our next thing. What's up?
Can you go to the bathroom?
Yes, you got to do it. So I have another triangle. This one has a side length of 1 and a side length of 1. What is my length of my hypotenuse? So in order to find it, what do I have to do to both sides? I'm not going to multiply, so I need to set it up again. So I get that I have 1 squared plus 1 squared is equal to my x squared. 1 plus 1 is? 2. What's 1 squared?
1.
1 squared. 1 plus 1 is 2 is equal to x squared. How do I undo that square root? Or how do I undo that square?
Square root.
Take the square root of both sides. So x is equal to the square root of 2. What kind of triangle is this?
Isosceles.
It's an isosceles triangle. So if it's an isosceles triangle, what's true about the two angles?
They're congruent.
They're also going to be congruent. Well, if I know that one of them is 90, what is my other two triangles?
45.
45 and 45. Same thing's going to be true down here, 45 and 45. Are these two triangles similar? Yeah, and I can use a number of theorems. I can use side, side. I can use angle, and heck, I could probably even use side, side. So in that case, what's the scale factor from this triangle to this triangle? What did I do to each side? Multiplied it by, so how did I get from 1 to 3?
3.
Multiplied it by 3. How did I get from radical 2 to 3 radical 2? Multiplied it by 3. So my scale factor between these two was 3. So these triangles in math are a special right triangle. Special right triangle is a triangle that has certain features based on their properties. So this is a 45, 45, 90 triangle. And there's a shortcut that we can use because it is this special triangle in order to find that length of the hypotenuse given the legs, or vice versa. Find the leg given the hypotenuse. Just looking at this, do you guys have any guesses as to what I could do in order to find my hypotenuse based on the leg? What that shortcut might be? It's okay if it's a guess, we don't know anything yet. Cool, let's learn about it. So I will pass out the notes.
I don't even need that.
You sure?
Yep. No. Is that camera on?
That is on. I'm currently filming. This is for my university mentor. It's not about you guys, this is about me teaching, so that the focus itself is on how I teach.
And everyone that want one, get one.
So for special right triangles, if I am given the leg length, we'll call it L. I use a little fancy curly L in order to help justify it, in order to help simplify that it is the length itself. I can find that length of the hypotenuse, h, by taking my leg length and multiplying it by radical 2. So if I know what the leg length is, I can find my hypotenuse by taking that leg and multiplying it by radical 2. So if you want to write that down, show those things, because essentially what we did was, well, if we set it up, in our first case, we found that that was going to be the square root of 18. The square root of 18 became 3 radical 2. In our second example, we had 1 and 1. We squared both of those sides, took that square root in order to solve for our hypotenuse, and that hypotenuse was radical 2. So with 45, 45, 90 triangles, no matter which one you have, as long as it is a 45, 45, 90, that property of, well, if I have the leg, I can find the hypotenuse by taking that leg length and multiplying it by radical 2. So if I'm looking at the first example, I have the fact that it's a 45-degree angle, and I have one of my legs is 4. So in order to find that hypotenuse, I can do two things. I can actually do 3 things. I can set up the Pythagorean theorem and go, well, if this is 4, then this is also going to be 4. 4 squared plus 4 squared, this is the square root. 4 squared plus 4 squared equals x squared. I can set that up and go, okay, well 16 plus 16 is equal to x squared. So x should be equal to, or x squared should be equal to 32. X is equal to the square root of 32. Square root of 32 breaks down to be 16 and 2, 4 and 4. So x should be equal to 4 radical 2. My 4's were allowed to come off the bus, and I got 4 radical 2 in the end. Or, because this is a 45, 45, 90 triangle, the length of my leg is 4. In order to find that hypotenuse, I need to take that 4 and multiply it by what? So that was just applying the Pythagorean theorem in order to say that, well, I can find that x is equal to 4 radical 2. But with this being a 45, 45, 90 triangle, I can shortcut that entire method, right? I don't need to do that whole step every time I solve for it. Because I'm looking for the hypotenuse, in order to find what that hypotenuse is going to be, I take my leg and I multiply it by radical 2. Can you guys see that? So in this case, what was the length of my leg? It was, that's my hypotenuse. My leg is 4. So in order to find the hypotenuse, because it is a 45, 45, 90 triangle, I can shortcut this entire method. I don't need to set it up, do 16 plus 16 is equal to x squared. Because I know that my leg length is 4, my hypotenuse is my leg times radical 2, so it's 4 radical 2. So with the 45, 45, 90 triangle, it is that special case of I can shortcut. So do we see where that 4 radical 2 came from? Yeah? Cool. Sort of, yeah. It's in that case, it's, yeah, in a sense, it is kind of like an equal image. So in this case, I can solve this 2 ways. I'm going to actually use a similar triangle idea. Because of this triangle, because this is 45 and this is a right angle, and this is 45 and it's a right angle, these 2 triangles are similar by angle. Because of that, I can actually set up my proportion in order to solve for that missing side. I'm going to set my proportion up as leg over hypotenuse. And I'm going to start with my small triangle. I'm going to start with my mini guy. And if I forget what my mini guy looks like, I'm going to always just draw him up here. This is 1, this is 1, this is radical 2. And I can orient that any way that I need to in order to see its relationship to that of the big triangle. So in order to set up that proportion, because all of these triangles are going to be similar through angle, I can say that, well, my short leg length, my small triangle has a leg length of 1. What's my hypotenuse of my small triangle? Radical 2. And that should be equal to my leg of my big triangle. What's my leg of my big triangle? 7. And what is my hypotenuse of my big triangle? X. That's what I'm trying to find. So when I set up that proportion, how do I solve for x? I'm going to cross multiply. So 1 times x is x, and then 7 times radical 2 is 7 radical 2. Cool. So we now have a couple ways that we can solve for that 45, 45, 90. We can set up our proportionality statement and solve for that missing side. We can set up the Pythagorean theorem. Because this is 45, we know that the other side is going to be 7. We can use the Pythagorean theorem to solve. Or, like our shortcut is, well, if we are looking for the hypotenuse, we can take our leg length and multiply it by radical 2 in order to find that in the end. So just to talk about that shortcut a little bit, our leg length was 7. So our hypotenuse is going to be that 7 times radical 2. That's going to be that x value. So if I'm looking at the Second one, I'm gonna use my mini triangle again. I'm just gonna flip them over real quick. That'll help me set that up. 1, 1, radical 2. So with those sides, I'm gonna set up my relationship. It's gonna be leg over hypotenuse. My leg of my mini triangle is 1. What's my hypotenuse of my mini triangle? Radical 2. What is my leg of my big triangle?
7 radical
7 radical 2
2, and then x.
over x. See if you can't set that up, cross multiply and solve. What you got?
Okay, so I'm just gonna do
Yes.
this one,
Yep. Okay, so then from there, what is the square root of 4?
which is 2.
Mm-hmm.
So I just send that 2.
Yep, it is.
And it's 14.
Bingo.
Oh, okay. Thank you.
Yes. Well, what's the square root of 4? 2. So it's gonna be 7 times. So it's 7 square root of 4. What's the square root of 2? So it's 7 times 2. Yeah. And when we take that square root, we're gonna drop that radical. Never do it again. So it's gonna cost. So 1 times x is. It's gonna be equal to this. So when we add that, multiply just the thing for that measure. So there's 7 times radical 2 times radical 2. It's gonna be 7. Absolutely. And then what's the square root of 4? 2. So we're gonna do that in some points. So a lot of us seem to be getting the hang of this. We do that cross multiplication. We see that, okay, 1 times x is going to be x. When we multiply 7 radical 2 times radical 2, what numbers am I going to multiply? Am I going to multiply that 7 by that 2?
Yeah.
No, not right now. When I multiply numbers, I need to multiply numbers that are all in the same place. This 7 is outside of that radical, so I cannot multiply it by any of those 2's. I can only multiply the numbers that are both under that radical.
I just have to rewrite it.
What's up?
You have to rewrite it.
No, so like I can write it just like this. So when I multiply this out, I can't multiply 7 by any of those, but I can multiply radical 2 times radical 2. When I do that multiplication, what's radical 2 times radical 2? Radical 4. So it becomes 7 radical 4. And some of you guys do have that answer written down. But what is the square root of 4? 2. When I take that square root of 4, I drop that radical. I took that square root. I performed that operation. So I do not need to rewrite that radical in the end. It just becomes 7 times 2. And then 7 times 2 is? 14. So the final length of that side opposite is going to be 14. Do we see where that 14 came from?
Yeah.
So that is the case of when we see that it is a 45-degree angle. Same thing is going to occur when we have both of the side lengths. So instead of giving us that this is going to be a 45-degree angle, it just tells us that it's isosceles. Guess what? It's still going to be a 45, 45, 90 triangle. So just because it doesn't necessarily tell us the angle measurements, if this is an isosceles triangle, I think Andrew helped us out at the beginning of class, if this is an isosceles triangle, what's the measure of one of those angles?
down the back side, guys.
Yeah, that's my fault. It's stapled weird. I was gonna say, this is your back page. So if I know this is an isosceles triangle, and I know that I have one of my angles is 90, those two other angles should also be the same to add to that full 180. So I get 180 minus the 90 that I know gives me 90 degrees left. Because this is isosceles, I know that these have to be congruent. Exactly. So they're going to be congruent. So I'd have to divide this by 2 in order to see that, oh, this is indeed going to be a 45, 45, 90 triangle. So I can apply those same theorems. Do you guys want to try the shortcut technique? Yeah? Cool. So in order to apply the shortcut, we need to find our hypotenuse by taking our leg and multiplying it by radical 2. So what's my leg in this case?
5 radical 2.
5 radical 2. And what do I need to multiply that by?
2.
Radical 2. So I set up that multiplication. I have 5 radical 2 times radical 2. Can I multiply that 5 by 2?
No.
No. That number is under the radical. They do not multiply. Yep, so radical 2 times radical 2 gives me radical 4. So I have 5 radical 4. And we already know what the square root of 4 is. We just did in that previous example. What's the square root of 4? 2. So it's 5 times 2, which is
10.
10. Cool. That's that shortcut. Because we know what that leg is, we can take that leg of 5 radical 2, multiply it by that radical 2 in order to find that my hypotenuse should just be 10. Ready to move on?
Yeah.
Sweet. Let's get some more practice with these. So looking at these triangles specifically, if I know that my leg is 8, what would be my hypotenuse?
1.
Not 1.
Wait. What's our hypotenuse again?
So if I'm trying to find my hypotenuse, this length here, and I'm given the leg is 8, how do I find the hypotenuse? What am I going to multiply that leg by?
Oh, radical 2.
Radical 2. So when I do that multiplication, it's going to be 8 times radical 2, which is not as a decimal, just keep it as that radical. Let's set it up. Do you guys want to see the similarity setup? A couple of similar triangles might help you out. See what multiplication needs to happen. Cool. So we're going to set it up the same way. 1, 1, and radical 2. Don't be afraid to draw that mini triangle to help you guys see what multiplication needs to occur. So I set it up as my leg over my hypotenuse so I don't get confused. What is my leg of my mini triangle?
1.
1. What is my leg of my big triangle?
8.
8. What is my what is my hypotenuse of my big triangle? Or my small triangle?
Radical 2.
Right. What is my leg of my big triangle?
X.
Not x. 8. What is my leg of what is my hypotenuse of my big triangle? X. That's what I'm trying to solve for. That's my fault. So when I set that up, it is leg over hypotenuse, so 1 over radical 2 should be equal to my leg over my hypotenuse of my big triangle. In order to solve for that length, what do I have to do? Cross multiply. I get that x should equal 8 radical 2.
Wait, even the way you accidentally set it up the first time, wouldn't that still work?
Absolutely. So if I wanted to set it up the other way, say I wanted to set it up as little triangle on top and big triangle on bottom. So if I set this up as little over big, I could say, okay, well my little leg is 1, my big leg is 8. And that should be equal to my little hypotenuse, which is radical 2, over what's my big hypotenuse?
So X.
I don't know.
Yes.
So in order to do, and then when I do that cross multiplication, the same multiplication occurs. So if you want to say, if you want to do your little over big, perfect. If you want to do your leg over hypotenuse, perfect. And you can flip both of those. Say you want to do big over little, that works as well, or hypotenuse over leg. As long as the cross multiplication is set up, you'll be fine. But can I compare my little hypotenuse to my big leg? So if I'm looking at this length here, can I compare this length, my hypotenuse, to my leg? Do they hold any relationship at all? No. So when I compare those, I'm never going to set that fraction up. That is not going to be something that I do in order to solve. Those lengths have no relationship, therefore I will not set them up equal in that way. So looking at the second one, do we want to see if we can't use our shortcut, or do we want to set up the proportion? Shortcut? Alright, so using that shortcut idea, I know that my leg is radical 2. In order to find what the hypotenuse is going to be, I take my leg and I multiply it by radical 2. So in order to find my hypotenuse, in order to find x, what am I going to set up?
Radical 2 times 2, right, or no?
It's not radical 2 times 2.
Radical 2 times radical 2.
It's going to be radical 2, my length of my leg, times radical 2. So when I do radical 2 times radical 2, I get
Radical 4.
radical 4. And what's the square root of 4? Dos. Cool. How do I feel about it so far? Alright, so that's finding a hypotenuse. In order to find the hypotenuse, I take my leg and I multiply it by that radical 2. And I can set up my proportion in order to solve that if I need to. Now we need to solve for the leg given the hypotenuse. So an easy way to get started is by setting up that same proportion. Instead, my variable for x is going to be a leg now instead of the hypotenuse. So when I'm given the hypotenuse, in order to find the leg, I need to set up a proportion, or there is a shortcut. So in order to set it up, I want to make sure that I put my leg over my hypotenuse. I'm going to draw my mini triangle with 1, 1, radical 2. We know that that's radical 2 because we set it up and solved for it. So what is my leg of my mini triangle? 1. What's my hypotenuse of my mini triangle? Radical 2. What is my leg of my big triangle? X. There we go. And what is my hypotenuse of my big triangle? 18. Cool. So I set up that proportion. You guys see where I got that proportion from? I'm comparing my small triangle to my big triangle, and I know that they are similar because they share those same properties. I know that this is a 45-degree angle, and I know it's at a right angle, so they are similar by angle similarity. So then from there, I can set up that proportionality statement and say that those things are indeed going to be equal. From there, I need to solve for x. In order to do that, I need to cross multiply. When I cross multiply, what's 1 times 18?
18.
18. What is x times radical 2?
Radical 2x.
X, right? Yeah, radical 2x. I'm going to write it as x radical 2. Absolutely. So now I need to isolate my x. I need to get x by itself. How do I do that? I'm I'm going to divide by
X,
radical.
uh,
So I have x should be equal to the 18 over radical 2. Do you guys remember last week when we talked about radicals in the denominator? Can I have any radicals in the denominator? I know you weren't here. I cannot have any radicals in that denominator slot. So in order to get rid of that radical, I'm going to write this fancy little thing. No rads in Dino. Don't ask me where Dino is or who rad might be, but there's no rads allowed there. With no radicals allowed in the denominator, I need to multiply by that radical in order to get it out. You guys remember from your worksheet how we multiplied by that denominator in order to get rid of it? So we have to multiply it by my radical in my denominator. What is my radical in my denominator?
2.
Radical 2. So I need to multiply by that whole thing. I need to multiply that by a radical 2 over a radical 2. That is my radical in my denominator in order to help me rationalize. When I say rationalize, well right now that is a 18 over an irrational number. And I cannot divide by an irrational number because it's a number that goes on and on and on and on and does not end. So I can't have that denominator down there as that radical because that's a number that does not work out nicely for me. So when I do that, I multiply 18 times radical 2. What's 18 times radical 2? 18 radical 2 has no number that works out nicely for it. It's a number times a radical. I cannot multiply those two together. One's outside, one's underneath. Those don't multiply together to become radical 36. That would just be 18 radical 2. And then what is the square root of 2 times the square root of 2?
4.
It's going to be the square root of 4. Or something that we can talk about, something that we talked about a little bit in that class is, okay, what is the square root of 4? 2. So if I'm multiplying a radical by itself, I should get just back that number underneath the radical. So what essentially I'm doing is I'm multiplying by that denominator in order to get rid of the radical in the end. So I multiplied radical 2 times radical 2, and I got back the number that was underneath the radical. So then I have 18 radical 2 over 2. Can I simplify that? So if I'm looking at it, I can rewrite this as 18 over 2 times radical 2 over 1. What's 18 divided by 2? 9. So I should get 9 over 1 times radical 2 over 1. Do I need to write my final answer over 1? Can I just, isn't 1 just a placeholder in this case? Yeah? So with that as a placeholder, what is my final answer for my leg?
9 radical 2.
9 radical 2. There's extra lines there. That's essentially what we were doing up there and helping us rationalize and do all of those things. We knew that 18 was equal to that x radical 2. In order to solve for that x, we took that 18 and divided by radical 2. We couldn't have that radical in that denominator, so we had to rationalize it by multiplying it by that well-chosen one, that radical 2 over radical 2. That gave us 18 radical 2 over 2. Well, if we have a number over a number, we can perform that division. 18 divided by 2 was 9 times radical 2. So I know you're all anxious for it. There is a shortcut to this method. If we are looking for our leg, and we have our hypotenuse, we take our hypotenuse and divide it by that radical 2. So look at our two shortcut formulas here. If we're looking for our hypotenuse, we take our leg and multiply it by radical 2. So don't you think the opposite would be true in order to find the hypotenuse? In order to find the leg given the hypotenuse, I would take my leg and divide off that radical 2 on both sides. So we can see from this example to this example, well, in order to solve for leg, what do I have to do? Divide off that radical 2 on this side, divide off that radical 2 on this side to give me leg should be equal to h over radical 2. But we can't have that radical 2 in the denominator, so what did we have to do? We had to rationalize it. So if we had that h over radical 2, we didn't have to divide, but we had to multiply by something. What do we have to multiply that radical 2 by? Radical 2 over that radical 2. So in the end, I have h times radical 2, which is h radical 2. Can't do much about that one. And then what is radical 2 times radical 2? Radical 4. Square root of 4 is 2. So if we have whatever our hypotenuse is, we're going to multiply it by that radical 2 and divide it by 2. Or if it's something like this, we can use that radical 2 to solve things out. Everyone have everything written on the board? Sweet. I'll move out for a little bit. Cool. What is my value of x for the first one? How'd you get 5? So,
First I set up the proportion,
absolutely.
but
So-
since I know that like you can take a leg and like it just more simply put 5, it would make sense because it goes from 5 to 5 radical 2.
There you go. So I'm going to actually use the shortcut for this example. So if I'm looking for my leg, I know that my leg should be equal to my hypotenuse over radical 2. What's my hypotenuse in this triangle? What's my length that it gives me?
Radical 2.
5 radical 2. And in order to find what that leg is, I need to take that 5 radical 2 and do what? Divide that radical 2 off. 5 radical 2 over radical 2, what can I do with those radicals?
Couldn't you multiply them?
I don't need to multiply them.
They cancel out.
They're going to just cancel out. So using that shortcut technique, well, if I have 5 radical 2 over radical 2, well, think of it this way. If I had 5x over x, what does that become?
5.
5. Same kind of thing happens down here. If I have 5 radical 2 times radical 2, what am I left with? I'm left with 5. The second one is definitely going to be a little easier to set up that proportion. So I'm going to set up my proportion in order to solve for that missing length. My 1, 1 radical 2 triangle. Call him your mini guy, call him your friend, call him your buddy. He's going to help you solve for these missing lengths. So I'm going to set it up as leg over hypotenuse. What is my leg of my mini triangle? 1. What is my hypotenuse of my mini triangle? Radical 2. What is my leg of my big triangle? X. And what is my hypotenuse of my big triangle? 100. How do I solve for x? No, you're right. I'm going to cross multiply, so I do that cross multiplication. What is 1 times 100? 100. What is x times radical 2?
X radical 2.
radical 2. Do you guys see where I'm getting those lengths from? So when I set up that proportion, I do that cross multiplication. When I perform that cross multiplication, the first thing that I multiply should be equal to the second thing that I multiply. That cross multiplication occurs. So in order to solve for x, what do I have to do? So I'm at that step. I need to get x by itself. What do I have to do? I'm going to divide both those sides by radical 2. So this becomes over radical 2. This becomes over radical 2. If I have x radical 2 over radical 2, what happens with those two radical 2's?
Cancel out.
They cancel. So x should be equal to 100 radical 100 over radical 2. Can I have that radical in the denominator?
No.
No, I cannot. No rads in deno. So when I have that